In this video, we will discuss about this macromolecular crowd application, that is Dextran 40 kilodalton, and its concentration that is used is 300 milligram per ml, and reaction time is 27 degree. Reaction temperature is 27 degree and reaction time is 1 hour. So before going into their results, we will understand what they have finally concluded about this macromolecular crowder. So what they say is that this macromolecular crowder can enhance the cell surface enzymatic activity. And what are the things that it can do? That it will increase the depositions. It will increase the depositions of this substrate, and it will reduce the diffusion of the substrate within the cells, and it will decrease the exchange of other things. So in overall, what it will does is it will enhance the enzyme substrate interactions that can be seen here. These are the enzymes and these are the substrate that are interacting, and it will try to avoid the open spaces. It will try to cover, Dextran will try to cover up the open spaces from where the substrate might enter into the cells. That's why it will reduce the diffusion rate. And they have optimized these macromolecular crowder conditions in order to convert different blood groups into the universal blood group. And the macromolecular crowder that they have used is for Dextran 40 kilodalton and at 300 milligram per ml concentrations, and they used this following blood group, that is A plus, A positive, B positive, AB positive and B negative blood group, and convert them into their target is to convert them into the O positive, O positive, O positive and O negative blood group respectively. The enzymes from their studies and from the literatures, they are able to find the enzymes that can cleave off the excess carbohydrate structures in their respective blood group. And what they have find out is that A positive uh, excess carbohydrate structures can be cleaved off using EMG 109. Similarly, B positive excess carbohydrate structures can be cleaved off with sp3gh98fl. And AB positive, they are able to find out two different enzymes, that is EMG H109 and sp3gh98cd. And B negatives, for B negative cells they use the same enzyme that they use for AB positive cells, that is sp3gh98cd. And the enzyme concentrations that they have used is this 1 nanomolar per ml, 0.013 nanomolar per ml and 1 nanomolar per ml for EMG H109 and 0.057 nanomolar per ml for sp3gh98cd. This is too effective, and similar concentrations they have used for B negative cells. And they did their experiment in two different conditions. First one is without crowded, that is without using the Dextran, and second one is with using the Dextran. And they have checked their uh, blood um, blood cells after their treatment with the enzyme using FDA approved uh, equipment device. I'm not able to recall the exact name. And how this score can be analyzed is that when the score is greater than 0, it indicates that there are some antigens of the A plus positive cells are present, or for the second case the B positive antigens are present, and respectively. And these things will continue. So when they do not use any crowded molecules, in 1 hour they are able to see the +4 score for this A positive enzymes trying to convert into the O positive enzyme using this EMG 109. But when they use the Dextran, the crowded score, the score is 0. And similar things they did it for other blood groups, and they are able to see positive results when they do not use any crowded after 1 hour. But when they use the Dextran 40 kilodalton or the macromolecular crowder, they can see the 0 result in all the cases. Indicates that their macromolecular crowder approach works well towards converting different blood group into the universal blood donor group, and these things can be used, and this approach can be used later on or in future, where wherever there is a scarcity of blood demand, to convert different blood groups into the universal donor blood groups. So this is what their applications of the macromolecular Crowder approach that they have presented in the paper. So that's all for this video. If you need to understand more about this approach in detail, you can go through the reference that has been provided in the description. That's all for this video. Thank you for your time.